Hello everyone, welcome back to my YouTube channel. This is Arshini from Sri Venkateshwara College of Engineering, Bengaluru, currently pursuing first semester in the Department of Electronics and Communication Engineering. My today's subject is Introduction to Civil Engineering and the presentation is on solving numericals based on centroid. Firstly, let us see the definition of centroid. Centroid of a body is a point at which the whole area of the plane figure is assumed to be concentrated. It is represented by CG or G. The centroid of gravity are at the same point. Centroid also called moment of inertia. Next, let us see steps for solving a problem. First step is we have to assume the reference x and y axis if it is not given in the question. And the second step is we have to check the figure if it is symmetric or asymmetric. And the third step is if the figure is asymmetric, then we have to divide the whole figure into known geometrical sections like rectangle, triangle, semicircle, quadrant, etc. And the next step is then we have to determine the centroid of individual geometric from the figure reference x and y axis using the table. Now let us see the problem. This is a given figure. So this is a given figure. Here we have rectangle, semicircle and also a triangle. Here the figure is asymmetric, that is if we cut the figure it is not going to cut in symmetrical axis, so we have to divide this figure into known geometrical shapes that are so we have to do first we have to form the table. So in the table first it will be the component and then area and then centroidal distance from x-axis and then moment of area about x-axis and next is centroidal distance from y-axis and then moment of area about y-axis. Now let us see the first. I'll take here the first component as rectangle and the second component as semicircle and the third component as triangle. So rectangle first component is rectangle. Now let us see the area. First let us see the area of three of them. So rectangle formula, area formula is breadth into depth. Here we have the rectangle. The depth is 6 and the breadth is 9. So 9 into 6 it will be 54 and the semicircle and next is semicircle. Formula for semicircle is pi r square divided by 2. So here total depth of the semicircle is 6. So radius is half of the semicircle. So half of the semicircle is 3. So pi into 3 square divided by 2. So we'll get approximately 14.14. And next is triangle. So area of the triangle is half into base into height. So half into base is as you all know base is 3 and the height is 6. So if we calculate this, we'll get 9. And next is centroidal distance from x-axis, that is considered as y in millimeters. So formula for centroidal distance from x-axis is d by 2. That is d rectangle d is 6 divided by 2. 6 by 2 is 3. So formula for semicircle from the centroidal distance of x-axis is r. So as you all know, r is 3. And then triangle, his formula for triangle is 2 by 3 into h. 2 by 3 into h is, here you'll get h is all as you all know h is 6. So 2 by 3 into 6 is 4. And then moment of area about x-axis, that is a into y, that is 54 into 3 is 162 and 14.14 into 3 is 42.42 and then 9 into 4 is 36. And now let us calculate the centroidal distance from y-axis. Centroidal distance from y-axis, that is formula for rectangle. First component is rectangle. from rectangle, formula for centroidal distance is b by 2, that is rectangle 9 by 2, sorry, b by 2 is 9 by 2, that is 4.5 meter. And then the semicircle is minus 4r by 3 pi, minus 4r by, here 4 minus 4r by 3 pi. So 4 into, as you all know, 3 r is 3 divided by 3 pi is 9 into 42, that is the 9.42 is equals to minus 1.27. If you check the calculator, if you put this value in the scientific calculator, you will get minus 1.27. And then triangle, and the last component is triangle. So centroidal distance from y-axis is 9 plus 1 by 3 into b. So formula is 1 by 3 into b, but here we are calculating it from the y-axis. So here it is, this formula is 9, so 9 plus 1 by 3 into b. So we have to include even this value. So this value is 9, so 9 plus 1 by 3 into b, 1 by 3 into b. So b value is 3, so that is breadth is 3, so 9 plus 1 by 3 into 3 is 10. And then the last is moment of area about y-axis, that is ax, that is 54 into 4.5, you will get 343, and 14.14 into minus 1.27, you will get minus 17.95, and 9 into 10, you will get 90. So now we have to calculate the x bar. By this we have to calculate the x bar and y bar. Before that, we have to calculate summation of A, that is summation of area. We have to add all three areas. So we'll get 77.14, and the summation of AY. Summation of AY is all the three values. We have to add all the three values in the column. So we have, by that we will get 240.42, and then summation of AX. We have to add summation of AX, that is three values in the column of AX. So it is 315.05. Now let us calculate x bar and y bar. X bar is equals to summation of ax divided by a. Formula for x bar, calculating x bar, is summation of ax divided by a. As you all know, summation of ax is 315.05 divided by summation of a is 77.14. So by dividing this, you will get 4.084. And the y bar, to calculate y bar, the formula is summation of ay divided by summation of a. Summation of ay is 240.42 divided by summation of a is 77.14. By dividing this, we will get 3.1166. So that will be the final answers for x bar and y bar. Hope you liked this video. Please like, share and subscribe to my channel. Thank you.